Hi there, and welcome to this new part of the Python programming series. Today, you're going to write your very first program in Python. In this lecture, you're going to write your first program in Python. We'll be using Visual Studio Code from now on, so if you haven't installed it yet, follow the instructions from the Install and Configure Visual Studio Code lecture. Also, make sure that you have Python version 3 set up on your computer, as described in the video Set up Python on your computer. Let's start by opening VS Code. We're going to create a new file by clicking File and select New File. A new file gets created with the name Untitled1. Have a look at the status bar at the bottom. The status bar is enabled by default, but if you can't see it, go to View, Appearance, and select Show Status Bar. The status bar tells us that the newly created file can hold plain text. We'll change that in a moment, but first type the following in the editor window. Print Hello World. Now click File again and choose Save As. Name your file firstprogram.py and save it. The py extension here denotes a Python source file. You should name all your Python source files according to this pattern: xyz.py, where xyz should provide a concise description of what the code does. After saving the file, right-click in the editor area and select Run Python File in Terminal. Visual Studio Code adds a new panel below the editor, and you should see the text Hello World displayed in the terminal. The print here is a built-in function that lets us output text to the console. We must write it all lowercase. Otherwise, it wouldn't be recognized as a valid function name. Let's change the print to print with a capital P and see what happens if I try to run the file again. As expected, we've got a name error. I undo the change to get rid of the error. Now let's talk a bit about the print function. An opening parenthesis follows the function name print. Then, between double quotes, we provide the text to be output: Hello World. And we end the statement with the closing parenthesis. We must surround the text to be printed with quotes. You can also use single quotes. Python won't complain. Thus, both of the following statements will work. You need to be consistent. Either use single quotes or double quotes for your strings. Don't start with a double quote and end with a single quote, or vice versa. Otherwise, you will trigger a syntax error, as in the following example. Now I remove this faulty line and let's print something else. Print Hey Steve. Feel free to use other names. Actually, you can print anything you'd like, just make sure it's surrounded with quotes. Also, start each of your print statements on a new line. Use triple quotation marks to delimit your text if it must span on multiple lines. The following statement will appear as it is in the terminal. Finally, don't forget to save your changes by clicking File, Save, or use the shortcut Command-S on a Mac or Control-S on Windows. You can run your program whenever you wish by right-clicking in the editor area and selecting Run Python File in Terminal. Congrats! You just implemented and successfully ran your very first Python program. You made the computer print various texts. Next, we're going to write a program that waits for user input. Computers can perform all sorts of calculations blazingly fast and output the results in some form, typically by displaying them on the screen. That wouldn't be very useful if we couldn't feed the computer with user data. In this section, we're going to create a program that waits for user input and produces the output based on what the user entered. Open up VS Code and create a new file by clicking File and select New File. A new file gets created with the name untitled1. Save the file using File, Save As, and name it userinput.py. After saving the file, type in the following statement. It's important to type it as you see it. Name in lowercase equals input, open parenthesis, the text, type your name between double quotes and close parenthesis. Now, what are we doing here? Input prompt is a Python function. It prints the prompt string to the terminal and then waits until the user types something and hits enter. The function returns what the user typed and stores it in the variable called name. A variable is a container that can store a value we want to use later in our program. So the name variable stores the value returned by the input function. We assign the value using the assignment operator. Next, type the following statement in a new line. Here, we create a formatted string literal using fstrings and assign it to the variable called message. The code f hello name creates a formatted string by replacing the expressions between curly braces with their values. If name has the value Michael, the result will be hello Michael. We're going to talk about strings and string manipulation in more depth later in this course. Now, type the last statement. The print function should be already familiar to you. It outputs the value of the text variable to the terminal. Let's summarize what we've implemented. First, we prompt the user to enter a name. Once the user hits the enter key, we store whatever she entered in a variable. Next, we create a new formatted string literal that greets the user. And finally, we print the text created at the previous step to the console. Now it's time to test our program. Right-click anywhere in your editor and select Run Python file in terminal. Type a name. I enter Oscar. Press enter when you're done, and here's the result. We've just implemented an application that creates an output based on what the user entered. That's a big step forward compared to our first program. High-level programming languages have a human-friendly syntax. The code written in a high-level language is way easier to read compared to the binary code. However, as your programs grow in complexity, it becomes harder to understand its logic without additional information. So far, we've implemented 2 short programs, and I explained every statement. This approach works for programming courses and books. You type in the code while following along with the instructor. That's usually not a feasible alternative when coding in real life. Wouldn't it be great to include some guidance in the source code itself? To explain what your code does? That would help other programmers who may read your code. It might be useful even for yourself, especially if you have to look back at your code a couple of months from now. Luckily, each high-level programming language provides the means to include short, inline explanations in the code. These are lines of text called comments. In Python, a line of text that starts with a hashmark sign is a comment. The computer doesn't try to interpret or execute such lines. They are exclusively meant for humans. So here's our code from the previous section. You may remember what each statement does. However, added comments can clarify everything in an instant. Python also supports multiline comments called documentation strings. A doc string starts and ends with a triple quotation mark, and it's used to provide longer explanation when necessary. The triple quotation mark that ends a multiline doc string should be on a line by itself. Having that said, you don't have to comment every line of code. So, when do you write comments? It's a good idea to explain parts of your code that provide specific functionality. You should also comment code that's not straightforward or to clear up confusion. Finally, here are some rules for writing good comments. Comments should be complete sentences, but keep them brief and concise. If your code changes, make sure to also update the comments if required. Helpful comments can help understand your code faster, and as a consequence, reduce the time required to maintain or enhance the program. We've used variables in the previous lessons. They are containers used to store data that can be accessed or changed while the program is running. A variable is a dedicated location from the computer's memory. We tag it with a name that allows us to identify it later. Then, we can put a value in it. Alright, let's open up VS Code. I create a new file as usual and save it as variables.py. In Python, you create a variable by typing a name. The name represents the data that you want to hold in that variable, so better provide a meaningful one. Say that you need a variable that stores the player's name. Now, you could name your variable x or n or anything that comes to your mind. But how about this version? It's definitely a better choice as it describes clearly the purpose of this variable. We've just created a variable called name, and we used the equal sign to store the value John in it. It's like saying, hey computer, here's the variable called name. Store the value John in it. Technically speaking, the value John is a string literal. We call literals predefined values that cannot change. The equal sign is called assignment operator, which makes sense as it actually assigns a value. Now, after this line of code, the name variable exists, and it can be used to retrieve the value it holds. Bear in mind that you cannot use a variable before declaring it. Let's try to swap the two statements and see what happens. So I select it and press Command X and place it here using Command V. If I try to run it, we get a name error. Name is not defined. So always make sure to define your variables before using them. Alright, let's restore our code to the working version. Variables can be assigned new values after defining them. That's why they are called variables after all. We can update the value stored in the name variable by assigning it a new value. Running this code produces the following output in the terminal: John and Steve. Now add another statement. And let's print it too. Now we've got John, Steve, and Sam. Besides providing meaningful, descriptive names for our variables, we need to follow certain rules called naming conventions. Variable names should be lowercase. For example, temperature starts with a lowercase t, or text equals done also starts with a lowercase t. We could change the name of the variable temperature to start with the uppercase T, but that's not recommended. If the variable name consists of multiple words, separate them using underscores, like in the following examples. Other programming languages use the lower camel case style for variables, where you start with a lowercase word and all successive words are capitalized, like first name, last name, and so on. Python prefers the underscore separated style as described in the Style Guide for Python code. In Python, variable names must start with a letter or an underscore. Other characters are not allowed. Type the following statement in a new line. Let's try to run it. The program triggers a syntax error. So don't start your variable names with a number. Let's fix this. All right. Here's a summary of the rules you need to follow when creating your variables. Provide short, descriptive names. Start your variable names with a letter. You can also use underscores, but that's a special case and we'll talk about its meaning later. Use the underscore separated style if your variable name consists of multiple words. Following the standard naming conventions and coding style will make your code look more professional and easier to understand. Now that you know how to declare and name your variables, let's dig deeper into how we can use them. We've seen what a variable is. A container that can hold different values with a name that allows us to identify it later and change its value if required. So far, we defined variables that can store text data. Python variables can hold many other data types, including numbers. Besides strings, numbers are the most common kind of values in computer programs. Now, open Visual Studio Code. Create a new file and save it as numbers.py. Let's define a variable. This line of code tells Python to create a variable called score and store the value 0 in it. Note that I haven't used quotes around the value 0. That would make it a string literal. Although we used the score variable to store numbers, now it holds a string. Bear in mind that most programming languages wouldn't let us change the data type stored in a variable. Once you declare a variable as a number, you can't assign it a string and vice versa. Python is less restrictive, but that doesn't mean that we should exploit this flexibility. If you want to change the value of the score variable to say 42 million, you should write. As you can see, I haven't used the thousand separator. That's because comma-separated values have a different meaning in Python. The following line does not actually change the score to 42 million. Python interprets the comma-separated value as a tuple, a list consisting of 3 elements. The comma separates the elements in a tuple. Thus, we assign the values 42, 0, and 0 to our variable. So let's print the value stored in our score variable. I run the file in the terminal, and here we go. The output is indeed a tuple, 42, 0, and 0. So make sure you don't use commas as thousand separators when defining number literals in Python. We can also use negative numbers. Try this. And now let's print our card balance. The output is minus 200. Now, what if we want to use a value that's not a whole number, like say 28.88? We can create decimals by defining number literals that have a point as decimal separator. Python treats the value as a float if the decimal point appears anywhere in it. All the following statements are valid. Don't use white spaces between the decimal point and the integer or the fractional part, else you'll trigger syntax errors. To create a negative decimal number, you just put the minus sign in front of it. As you can tell, defining numeric values in Python is effortless. So let's do some maths next. In this lecture, we introduce the basic arithmetic operations, that is, addition, subtraction, multiplication, and division. Start VS Code and create a new file called basicmaths.py. Let's create two variables a and b. I make a equal to 2 and b is 4. We can add them together using the plus sign and store the result in a new variable c. Python evaluates whatever is on the right-hand side of the assignment operator and puts the result in the variable from the left-hand side of the equal sign. Thus, the following code is not valid. Let's try to run it, and we've got a syntax error. All right, so let's remove this line and make sure to keep the operation on the right-hand side of the assignment operator, otherwise you'll get a syntax error as we've seen. The operator for multiplication is the asterisk. For division, we use the forward slash. So these are the basic arithmetic operators. You can't use any other signs or characters to perform these operations. For example, none of the following statements will work. So again, these are bad examples. Let's get rid of them. Python doesn't restrict us to perform a single operation. The following statement is completely valid too. Now, can you guess the result? What will be the value stored in C after evaluating this statement? Let me simplify this for you by replacing the variables with their actual values. Some may be tempted to execute the operations from left to right, like this. 2 plus 2 equals 4. Then multiply it by 4, so we've got 4 times 4, which gives us 16. Finally, subtract 4 from 16, and we have 12. Let's print out C and run the program. So why did we get 6 and not 12? That's because we ignored the order of operations. Most programming languages use the operator precedence levels that conform to the order commonly used in mathematics. Multiplication and division have higher precedence than addition and subtraction. In other words, if an expression has multiple operators, multiplication and division get evaluated before addition and subtraction. Thus, 2 times 4 gets evaluated first, which is 8. Then we add 2, and we get 10. And finally, subtract 4. So the result is indeed 6. We can override these precedence rules using parentheses. For example, we could do the following to add together the first two numbers before performing the multiplication. Let's rerun it. In this case, the result is indeed 12. Because of the surrounding parentheses, the addition 2 plus 2 gets evaluated first. So we have 4 times 4 minus 4. The multiplication 4 times 4 is performed next as it has a higher priority than the subtraction. Then we evaluate 16 minus 4, so we've got 12. If an expression contains operations that have the same precedence, Python evaluates it from left to right. Consider the following example. X equals 8 divided by 4 divided by 2. Python evaluates the first division starting from left. 8 divided by 4, which is 2. Then performs the second division, 2 divided by 2, and the result is 1. If we started with the second division, the result would be 4, because 4 divided by 2 is 2, and 8 divided by 2 would be 4. As you can see, the evaluation order matters. So these were the basic arithmetic operators, and we're going to introduce a few more in the upcoming sections. Alright, let's talk about string operations next. We've seen how to define string literals. Now, let's see some more advanced examples of using and managing text in our programs. Open up Visual Studio Code and create a new Python source file called strings.py. Next, create two variables and assign string literals to them. We can concatenate the two variables using the plus operator. The plus sign here is not an arithmetic operation. Instead, we're telling the computer to concatenate the string literals stored in part 2 and part 1 and put the result in the quote variable. Let's check the output by printing the quote variable. There should be a space between the two sentences. Let's fix the formatting issue. We can combine multiple string variables and string literals using the plus operator. So I can insert a white space by adding it here. And finally adding part 2 also. Now we've got the white space between the sentences. We could also create a formatted string literal, known as f-string. The formatted string literal was introduced in Python 3.6. It's a convenient way to create new strings by evaluating the expressions delimited by curly braces. Here's an example. The code f part 1 part 2 creates a new string literal by replacing the expressions part 1 and part 2 with the values stored in the corresponding variables. As you've probably noticed, the f string contains a whitespace separator between the two parts. Thus, the resulting string will be formatted correctly. Let me show you by commenting this statement out, and I'm gonna clear the terminal. And now let's rerun our file. As you can see, the sentence is correctly formatted because we included a space in the f string itself. Formatted string literals let us create strings that contain other strings, integers, or decimals. Let us type the following. This prints your name is Michael and you're 32 years old. Now let's try something else. Car equals Tesla Roadster, acceleration is 1.9, and the message equals an f string. The car goes 0 to 60 miles per hour in acceleration seconds. Finally, we print the message. And here's the output. We can include format code syntax within the curly braces of our expressions. Write the following code. Pi equals 3.14159265359. Next, I construct the message using an f string. Print the message, and it outputs the number pi is approximately equal to, and this long number. Now, usually you don't need that high level of accuracy. So let's display only 2 digits. I'm gonna add a format specifier and tell that I only need 2 digits, and this is a floating point number. The output contains only 2 decimals. Using point2f, we specified that the value should be displayed with 2 digits. You can even get rid of the decimals completely by instructing Python to display 0 decimals. Python provides many other useful string features, so let's see some of the most commonly used ones. Given a string literal or a string variable, we can query its length, that is, how many characters it has. I used the len function here. When we run the snippet, it prints out 41 because the number of characters in the message variable is 41. The length will include punctuation and spaces as well. We can also count the length of Unicode strings. We can convert a string to uppercase. Upper is a string method that returns a copy of the string converted to the uppercase. Note that the original message remains unchanged. Printing the message variable will print the original string. The upper method has its counterpart that returns the lowercase version of a string. So I'm gonna call the lower string method here. There's also a swapcase string method that converts the uppercase characters in a string to lowercase and vice versa. I am not quite sure about the practical application of the swapcase method, but it's there if you need it. We can use the count method to get the occurrence of a substring in a string. Let's check how many times we've got the word stay in the original message. So the word stay appears twice in this message. I'll introduce more string-related functionality later on in this course, but this will suffice to get you started. In this lesson, we talk about a new data type called Boolean that can only represent the values true and false. Start VS Code and create a file called boolean.py. In Python, we define a Boolean variable by assigning the value true or false to it. The values true and false are not surrounded by quotes. They are not string literals, but instead reserved keywords used to create Boolean data types. As you noticed, the keywords true and false must start with a capital. The following statements are invalid as the names true and false, written as they are not defined in Python. The keywords true and false are special cases of integers. The value of true is 1 and false evaluates to 0. And here's the proof. We see 0 in the console because false evaluates to 0 and 42 times 0 is, well, 0. And if I replace false with true, guess what we get? Now we have 42 in the console because 42 times true, which is 42 times 1, is 42. Although the practical use of Booleans may not be evident at first, they play a crucial role in programming. We can control how our program behaves based on Boolean conditions. For example, we might use a Boolean variable isValidEmail to control the execution of the program. Initially, the variable is set to false. The isValidEmail variable becomes true once the user has entered a valid email address. After that, we let our program perform the next action, like loading a web page or showing registration successful dialog. We'll get deeper into Booleans and conditional logic in the next section.